Hello, welcome to all. This is Malesh from BBC Engineering College, Associate Professor of CSC Department. Now, this session I can explain about two-tree tree and by the basic operations like construction, insertion, searching, and deletion operation. So, two-tree tree is a balanced tree. So, the balanced tree is nothing but have some internal properties is there. That internal properties of in this two-tree tree is each internal node has either two or three children, and all the children should maintain at the same level, that is at the bottom level. So the two-tree tree is a combination of two node tree property and three node tree property. So what is meant by two node and what is meant by three node properties, let me see now. Just see the two node, that is node with two children are called as two nodes. A two node contains one data item value and with this which is the two children. Let you see the tree structure of two node. Here X is our data item and L is its left subtree and R is its right subtree, and it has some internal properties. The first that is that the left subtree elements is smaller than the root node of X and the right subtree elements is greater than of a root node, is similar to our binary search tree properties, and all children should maintain at the same levels. Similar to three node, so in this three node we have two data items maintained at the root position and it contains three children, that is left subtree and middle subtree and right subtree. The left subtree, see the structure of this three node tree. The left subtree elements is smaller than X and middle subtree elements are in between of X and Y, and the right subtree elements is greater than this Y. And again this is not a balanced tree and it is a binary tree. It is not a binary tree, but it must and should follow the binary search tree properties, and all children should maintain at the same level. So the combination of two node and three node structure is formed with our basic operations of like construction, insertion, deletion, and searching operations. So we have some certain rules for two-tree tree. So these are some splitting rule, matching rule, and redistribution rules are applied while construction of our two-tree tree for applying the operations. The splitting rule is applicable only for construction and insertion of operations in our two-tree tree, and redistribution and matching rules are applicable only in the form of deletion operations can be applied. So these are all some rules. We are applying some notations is used for redistribution and matching rules. See the slides. Yeah, see the slides. So these are the slides for applying some redistribution and matching slide and matching rules can be applied in the form of deletion operation. We can apply it. So see the redistribution rule. We can apply some redistribution and matching rules is there. So these are all very useful for while in the form of deletion of a particular element in our two-tree tree structure. These are some complicated redistribution cases, but not everything complex. So it is little bit some other difficult, but not easy. If you have understood concept, it is easy to redistribute the elements. So these are some matching cases also. See the matching cases. So in that we have some basic operations on two-tree tree. There are four basic operations like construction of creation of two-tree tree. Second one is the insertion, third one is deletion, fourth one is the searching. So in our see the first construction operation. So these are all some basic points related to searching. Searching is similar to the binary search tree. Searching is the similar process. Some example for searching of in a particular element. So that is the construction of our two-tree tree. Here we want to search 63. The 63 is compared to root node. The root node having two data items, 54 and 90. So 63 is in between of our particular data items. So we are going to the middle portion. In the middle portion, we have 72 item is there. So again, our searching element is compared to 72. So we are moving on left side. So the 63 is available, so we can directly print our searching element is found is there. Let's see this example to construct 2, 3 tree taking these elements like 14, 12, 9, 8, 7, 10, 18 and 16. And step 1, so the 14 is the root node that will be placed, and step 2, 12 and 14 are maintained at the same position because maximum 2 data items we can maintain in our 2, 3 tree construction, but we have to maintain some ascending order. We have to maintain the same data items placed in the one place. Coming to the step 3, the third element is 9, that will be placed like that, but it will violate the rule because maximum 2 data items we should maintain at the root position. So we are applying some splitting rule, that is the middle element is goes to the root, and 9 is splitted as a left subtree and 14 is splitted as a right subtree. So this is our splitting rule. After applying the splitting rule, the tree structures change like this, and all elements should maintain at the same level. So coming to the step 4, the next element is 8, that will be inserted in this place. So 8 is smaller compared to root node, it is smaller, so we have to insert as a left child. So 9 is there, but 8 and 9 we have to maintain the 2 data items in one place like this. And coming to the step 5, the next item is 7, so we have to insert as a left child of the root node 12. So here we can insert like that, but again we have to apply some splitting rule is there because maximum 2 data items we should maintain at the rooted position. So the middle element is attached to 12, and 7 is split as a left subtree and 9 is split as a right subtree. So 8 and 12 is attached to is the 2 data items in the single node position, and 7 is its left subtree element, and 9 is middle subtree element, and 14 is the right subtree elements. Coming to the next step, and the next element is 10, that will be inserted in between of 8 and 12 of the root node. In between we can insert is that 10 is the middle subtree of these elements. So this is the construction, and all elements should maintain at the same place. So coming to the step 8, the next element is 18. So we have to insert as a right subtree of our particular rooted node position of elements. So there is no problem for any applying of splitting rules. Yes, right. Same step 9, we have some violation of rules is there from 2, 3. Maximum 2 data items we should maintain, but we have some 3 data items are maintained, so we are applying splitting rule. 16 goes to attach it to this position, and 14 is splitted, and 18 is splitted like that. So again some rules are violated here. Maximum 2 data items we should maintain. Again we are applying some splitting rule. 12 goes to the root, 8 is splitted like this, and 16 is splitted like this. And finally this is our construction of all the elements. All children should maintain at the same levels. So this is the construction of our 2, 3 tree. So everything should maintain our bind search tree properties and including with internal properties. Thank you.